information theory and coding, we have two types of coding techniques. One is channel coding, another one is source coding. Our concern is confined on source coding. That means today our topic will be source coding. The source coding techniques will be applied when the message or information will be created, that is in the source. Under source coding, the design of a variable length code, a technique is taken where the average code word length of the code approaches to the entropy of the source, that means direct memoryless source. This coding techniques is known as entropy coding. Under entropy coding, here we will see two examples. One is Shannon Fano coding and second one is Hoffman coding. First we will talk about Shannon Fano coding, after that Hoffman. So under Shannon Fano coding, some algorithm is written and we have to follow this algorithm if we want to construct the code word from the symbol given. The first step of this algorithm will be the messages are fixed in the order of decreasing probability. That means the question some number is given in form of message bit. First arrange them in decreasing probability order. The second step of this algorithm is then divide the message set into two most equiprobable subset. That means the total list will be divided into two sets. Then the third step will be the message in the first set we denote as 0 and in the second set denoted as 1. Then the fourth step will be the procedure is applied for each set separatively until no further division is possible. And the last step is finally we get the code word. So these 5 steps will be considered when you want to convert a Shannon Fano coding system or a message symbol into the code word under Shannon Fano coding system. So here a problem is written. Find the code word occurring in the probability. These are the occurring of this probability for the symbol S1, S2, S3, S4. That means there are 4 symbols with their probability. And we have to find out the code word with their efficiency. So for calculation of this code word, we have to follow the steps that I described before. First step, the first algorithm step will be arrange all the probability with the symbol in decreasing order. So you write 3 columns. In the first column write symbol. In the second column write probability. And lastly code word. So in symbol write S1, S2, S3, S4, these 4 symbols. And then write their probability with decreasing order. So the decreasing order will be written as, the first decreasing order means topmost will be written in the or the highest bit will be written in the topmost column and the lowest bit will be written in the least column. So write here first 1 by 2, then 1 by 4, then 1 by 8 and lastly also 1 by 8. So these 4 probabilities are written in the decreasing order with their symbols. Here symbol is not written in the same order. So write it is S1, then S2, S3 and S4. After that, the second step will be, now divide them into two subsets so that two of them are equal probability. That means this total set is, we have to divide into two subset. If it is one set, then it will be, it should be divided into two subset, where the two set or two subset have equal probability. So if, see that if we add these two and these two, it will be written as 1 by 4, 1 by 2 plus 1 by 4 will be as 4 plus 2, that means 6 by 8. And if this, it is written as 1 by 8 plus 1 by 8, that means 2 by 8 or 1 by 4. One is 6 by 8 and another is 1 by 4. So these two are not equal probability. So I cannot add them directly. So I have to add them with the adjusting value. So what should I do? First we set this is as a set and this is another set, because this set have a probability half and this total value will also have a value of half. That means 1 by 8 plus 1 by 8 is 1 by 4. Again 1 by 4 plus 1 by 4, it is 1 by 8. So 1 by 4 plus 1 by 8 plus 1 by 8 equals to half, and it is also half. So that means these two are equiprobable. So we divide them by this way. Then put 0 or denote 0 the uppermost bit, that is, it is 0 and it is 1. Now this set is already separated because this set only contain one message bit, but under this set there is 3 bit. So again we have to divide this set into two equiprobable subset. So that means it is also written as 1 by 4 one set and 1 by 8 plus 1 by 8, it is have 1 by 4 also, and this value is also denote 0 and it is 1. Now we have remaining part, this S3 and S4 has this set also 2 message bit. So we have to again divide it into 2 separate sets. So one I write 1 by 8 as another set, 1 by 8, this 1 by 8 has one another set. We denote as 0 and this is 1. So our final code word will be, this is 0 because it has only one set and no further division under this set, therefore we denote as 0. In this case it is have 3 division. So it is written as 1 for S2, 1, 0. Because 0 is, after 0 there is no subdivision. So therefore we stop here coding as 1, 0. The set 3 has coded symbol or code word is 1, 1, 0. And the last will be 1, 1, 1. So it is our required code word. Now we have to find out the efficiency of this code word. For calculation of efficiency, we have to consider a formula, that is eta equals to h by h cap. Now this is our previous formula. The value of h equals to summation of I equals to 1 to m pi log 1 by pi, and the value of h cap will be I equals to 1 to m pi into ni. After putting the value, we get as pi, that means half. Pi means for P1. For S1 it will be P1. So P1 will be half into log 1 by half, that means log 2. Plus second one will be 1 by 4 log 4. These are all base 2. Then one by 8 log 2 8, and again 1 by 8 log 2 8. For denominator, the formula will be denoted as pi will be the probability, that means half, into ni. Ni means the length of the code word, which is for first one is 1. So it is 1. Plus for second one, the length of the code word is 2. For third one, the length of code word is 3. And for fourth one, the length of code word is also 3. So by calculating it, the efficiency of this code word is denoted as 1.75 by 1.75, or it is 100%. 1 or 100%. So it is our desired answer. So here is another problem in Shannon Fano coding. This problem is find out the code efficiency of the following code. Symbol and probability as given. X1 value will be 0.8, X2 value will be 0.4, X3 0.2, X4 0.08 and X5 0.02. So similar to our previous process, for calculating the code word, the first step will be arrange the symbol with their probability in descending order. So first one will be 0.8, then 0.4, then 0.2, then 0.08 and lastly 0.02. Note that here the problem is given in also decreasing order. So therefore we no need to arrange them, rearrange them. But in your problem, if the order is not specified, then you have to arrange it in this way and with their symbols. Then the second step will be divide them into subset and with their equal probability. Two subset has equal probability. So here this is first, and after adding all these, that is 0.4 plus 0.2 plus 0.08 plus 0.02, what will be the value? Plus 0.4 plus 0.2 plus 0.08 plus 0.02. We add, when added 0.7, and it is near about to 0.8. So therefore the two subset will be, one is 0.8, another one is this total. Then we denote them, it is 0 and it is 1. Then this set has only one message bit, so it is defined. Now we comes to this. This set is again divided into subset with equal probability. So now it will be 0.4 and it is 0.3. We denote them, it is 0, it is 1. Again this is defined, and this there is 3 message bit in this subset, so it is again subdivided. It is 0.2 and it is 0.1, because 2 is this set and these two when added it gives 0.1 and it is another set. So we denote them as it is 0 and it is 1. Again this set has two subsets, that is 0.08 and 0.02. So again it is divided into two subsets. We put them 0 and it is 1. Note that this 0.8 is denoted here. For this 0.8, the message bit is represented here. These 4 bit, for this 4 bit, this is the subset, and all these subset is again divided in these two subset where the uppermost contain only 0.4 and all three in the other subset. Then this subset is divided into again two subset where 0.2 is one subset and 0.08 and 0.02 is another subset. And lastly these two are divided into two subset. So our code word will be it is 0 because here already 0 is given. For 0.4 it is 1 and 0. For 0.2 it is 1, 0. That means 1, 1, 0. This 0.4 is subdivided into this and this set. So this is as 1, 0, 0. Oh, sorry, 1, 1, 0. Now 0.2 is denoted here. 0.08, for 0.08 it is 1, 1, 1, 0. This 0.2 is denoted as 1, 1, 0. Note that this 0.2 subdivided as here, then here. That means it is here ended. For this is for 0.08, the subdivision will be 1, then 1, then 1, then 0. So 1, 1, 1, 0. And last will be 1, 1, 1, 1. These 4 are the code word. Now we have to find out the eta. The value of eta will be hx by L or h cap, as we denoted as. So the value will be 0.8 into log 2 1 by 0.8 plus 0.4 into log 2 1 by 0.4 plus 0.2 log 2 1 by 0.08, and last one by this way 0.02 will be written as, and the denominator L value will be pi into ni, that means 0.8 into 1. This code word contains 1 bit, so this is 1. Second will be 0.4 into 2 plus 0.2 into 3 plus 0.08 into 4 and 0.02 into 4. The value will be, total value will be, numerator is 1.65 and denominator is 2.6. If you calculate, you can get this two value, which is 0.63. So the value of eta equals to 63%. It is your answer. So here a problem is given to you. Find the code word for the probability of this symbol SI, where SI equals to 0.2, 0.4, 0.1, 0.03, 0.07, 0.05 and 0.15. You have to find out the code word and also find out the efficiency or eta. It is your task. Do it yourself.